Am I audible, Ali?
No.
Okay. See, Ali, I checked your homework. So, see, this one was fine. It's just that this is not how you write the derivations, na? When you're writing the derivation, write the entire derivation completely. In just 2 lines, you cannot end your derivation because this derivation comes for 3 marks. You have to write all these things. That let this be this. You will write everything like this. First, let charge Q1, Q2 be this, and they're separated by this, like this. And then you will tell F is equal to this due to Coulomb's law. The way we have done it in the class. That way you have to tell that this is due to Coulomb's law. Then you will tell electric field's formula, and then you will put, and then finally you will show that electric field due to point charge is coming this. And write both the formula in terms of K also, okay?
No.
And secondly, this wasn't well, Ali. First question was fine. This was correct. 311.4 was the exact answer. And you've written 312. That was right for the fourth one. First one, see, when you are writing, Ali, you have to show the direction. Okay, you have to show the direction of forces. How you're saying the net force is 0. Why are you saying that? So you have to show that if these 3 charges are there and if one charge is at the vertex, so you will show that one force will go here, whatever is the direction of forces that you will show. And then you have to write that this is the magnitude of first force, second force, third force. And when all of them are equal, then ultimately it's equal to 0. You cannot write your answer like this. This was incorrect. And then you didn't attempt any of the questions. So this I have to discuss. This paper was fine. It's just that you just need to write this properly. I will discuss this one with you. See, it says that consider 3 charges Q1, Q2. First one you didn't attempt. No, first one you did. This was done by you. Second you did. It says 3-point charges plus Q are kept at the vertices of equilateral triangle. So when it has put equilateral triangle, okay, and it is saying plus Q, they are present on all of it. Plus Q, and they are separated by L. So say determine magnitude and sign to be kept at its centroid so that the vertices remain in equilibrium. See, if you have a charge, let's say Q, so you will determine its sign. If let's say this is negative, so due to this positive, it will move towards it. Due to this positive, it will move towards it like this. See, their resultant will fall downwards. So this will cancel. So yes, negative charge will balance it. And then similarly, take one charge at the corner with these centroid separations. See, the centroid separation will be the centroid separation when you are taking, it will be L by root 3. So use that and calculate. You will get the value for the second. Then consider the charges placed. Okay, the figure wasn't given in this, no? Believe it. 4-1 said equilateral triangle, 3 charges, determine the resultant force on it. So it's the same question. If 3 charges are present like this, and this is 5 microcoulomb, this is plus 10 microcoulomb, this is also, this is minus 10 microcoulomb, right? It is saying sides are given 5 centimeter, it's given. This is in centimeter. So you need to convert micro into coulomb and centimeters into meters. It is saying determine the resultant force on A. A means one of the corners. So see, when you have ABC triangle is set. So let us see. 5 microcoulomb is A point. So you will mark this point as A. Then second 10 is B. So this is B, this is C. So this is your question. You have to calculate the resultant force on it. Will you be able to do it now, Ali?
Yes, ma'am.
Okay. And the fourth one, 4 equal point charges, 16 microcoulomb are placed on the side. We did this question in the class, Ali. We have done this. The same question we have completed. 4 point charges are there. Let's say Q. And all are same. Side is 0.2 meters. Okay. The side here is 0.2 meters. You have to calculate the force on any of the charges. So when you are calculating the force on any of the charges, see, due to this, it will be kq square by a square. Look, kq square by, first of all, you have to check the forces. This will be pointing like this will be pointing like this, and due to this, it will point like this. And then you will see their resultant will also point like this. So their additions resultant means with angle 90 degree, and whatever you will get the force, you will add it with these. That will give you the final resultant. What was difficult in this, Ali? Why didn't you attempt this? We did the same question in the class. Same. Any queries, Ali? Then what was the issue? Okay, let's continue this. So yesterday, Ali, when you joined the class, that time some of the portions were missed. This part was missed by you because yesterday's class also was started very late. So very much portion isn't missed. See, just the superposition part you couldn't write. When we say superposition principle of electric field, it is exactly the same as that of your forces. Means you have different charges present, and at a point you have to calculate the separate electric fields, and then you have to add it vectorically. Like we'll calculate individual electric fields, nth charges are present. You calculate the individual electric fields, and then you apply your vectors, add the resultant, and you will get the net electric field. That's it. Similarly to what we have studied. Okay, and one more thing that I told yesterday was that if we are calculating the net charge on any of it, if we are calculating the net charge, not net charge, net electric field, and net electric field, net force, if they come out to be zero, means both the fields are cancelling each other, both the forces are cancelling each other. We say that this point that we have obtained now is called as a neutral point. This is the neutral point that is obtained. So point at which electric field of individual forces or individual electric fields, they cancel each other due to individual charges. This point is termed as a neutral point. Like one question I discussed, which you missed. So I'll show you the question. Then we'll proceed with the point B and C yesterday we left. Two charges plus C and plus 4E are placed at this separation. Now we have to find out the point where electric field is zero. Net electric field zero, it should immediately come to your mind that this is the neutral point which it is asking. So if it is asking you the neutral point, so look, due to plus 4E, electric field will be pushed away because for positive charges, we have the direction away. And similarly, due to this positive, it will be moved away. So resultant is equal, EA is equal to EB. Also, Ali, please make arrangements of opening the camera also in the class. Now look, when you are calculating EA, now here your EA and EB both are equal. So EA, general formula of electric field due to point charge is KQ by R square. So EA becomes K into E divided by X square. And here we have K into 4E divided by A minus X whole square. Now, when you solve this, you get the value of X as A by 3. So A by 3 is from E. You will see from which charge the question is asking. If it's from plus E, you will write this. If it's from plus 4E, you will write 2A by 3 by using A minus X. Now, it depends on the question, but if the question hasn't mentioned anything to you, then directly you use any one of them and write by yourself from plus E, from plus to E, whatever you want to write. Okay. And electric field for a symmetrical system is zero. That this part I think you were able to catch in the class, no? From here you have joined.
Yes, ma'am.
Okay. So Ali, do you have the notes still here? Do you want to write? Just tell me about this part.
Yes, ma'am. I want to write.
Okay, just write it and let me know in the chat box. Then I'll continue from where we have left.
Done, ma'am. Can you go up?
Okay, let's continue. So this part you have written and this question also you have written. Yes?
Yes, ma'am.
Okay. We were on this point, calculation of this C point. Right. So let us continue with this one. See, when we were talking about A point, we saw the direction of electric field. So due to this positive charge and due to this negative charge, the electric field was towards one end, and this calculation you can perform yourself. Now, when we have this B point, so this point is situated 0.05 meters away from this plus. and total distance will become 0.15 meters from the negative one, because our task is to calculate the electric field, net electric field at this B point. So at this B point, see, due to the negative charge, electric field will be pulled towards it, and due to the positive charge, electric field will be pushed towards it. So this is the negative charge and this is the positive charge that we have. It means electric field is in opposite direction. So we need to subtract the electric field. So E1 will be equal to, when we are calculating E1, see, the lesser distance is this from the positive one. So for the lesser distance, we'll get a larger value. So we'll put that first. So Ali, you tell me, look at this. This is enough. You don't need that figure. Tell me, for the positive charge, what should be the electric field? Look, this is the point. This is the charge. How do we write the electric field? Due to a point charge. This is the point charge. This is the separation. Yes, Ali, answer.
A 10
K.
to the power minus 8
Yes,
by 0.05 square.
correct. By 0.05 square. Minus, for the second charge, negative.
A 10 to the power minus 8 by 0.05 square.
By?
0.05. 0.1 square.
Yes, 0.15 whole square, correct. So see, this you can calculate later. From this, if you take 9 into 10 to the power 9 into 10 to the power minus 8 common, you will be left with 1 by 0.05 whole square minus 1 by 0.15 whole square. This you can solve later. Newton per coulomb will give you electric field. Last point is this C point. See, E1 and E2. If you look carefully, Ali, the first charge magnitude is also 10 to the power minus 8. This is also 10 to the power minus 8. This separation is also 0.1 meter. This separation is also 0.1 meter. So magnitude of E1 and E2 will be the same or different?
Same.
Same. So let us write E1, E2 as E. This is our point C. Let's say this is the point C. This was left. So look, this is due to E1. This is due to E2. An angle we also know is 120 degree. So see, for the net resultant electric field, instead of writing this separately as E1 then E2, let us just write it as E, because the magnitude will be equal to KQ by R square only, where your Q is 10 to the power minus 8 and R is 0.1 meters. So net electric field will be, look, E1 and E2. So when you have E1 and E2, I am writing this as E square. E square plus this will be E square plus 2E into cos 120 degree. What's cos 120 degree, Ali? Minus half. Okay? Minus. So this is plus 2E square into minus half. Look, 2 gets cancelled. So you have root 2E square minus E square, which is root E square, which is equal to E. Means the magnitude of the resultant net electric field will be E, that is KQ by R square only. Means 9 into 10 to the power 9 into Q is 10 to the power minus 8. Separation is 0.1 whole square. Okay. So this you can write as 10 to the power minus 2. It will go up and you will get the answer in Newton per coulomb. Is that clear?
No.
Okay, please complete down this question. You written this part?
No.
Okay, please write for point B and C then. Then we'll start with some other topic. Okay, Ali. See, before understanding the dipole moment, let's understand monopole and monopole moment. See, mono from the term only. It's quite clear when we write the term mono. It means single. And pole term is used to represent polarity. So monopole means the elements which have single polarity. Means if they have positive charge, they'll have only positive charge. There won't be a mixture of any other charge. Negative, so it will be completely negative. So system having only one type of charge, okay, either positive or negative. For example, let's talk about electrons. Electrons are those species that are completely negative. You don't have any positive element into electron. So we will say electron is a monopole. Similarly, when we are talking about proton, proton is completely positive in nature. You don't have any element of proton. So we will say that proton is a monopole. So electrons, protons, and various other elements that just have that charge in them, they are called monopole. And when we talk about the monopole moment, Monopole moment basically means strength of the monopole. Strength of the monopole. So strength of the monopole is very easy when you have single polarity. We have studied the additive property of charges. So you can add all the charges together. When negative charge comes, you can subtract the charges. So for strength of monopole, it's like if I have a system of plus 2 coulomb, minus 3 coulomb, plus 3 coulomb and all like this. So I can, for calculation of the charge, I can simply calculate the net charge as plus 2 coulomb minus 3 coulomb plus 3 coulomb, and I'll get the net charge as plus 2 coulomb. So this is giving me a strength. Now look, this is a monopole, 2 coulomb, because it has only positive charge. Plus 3 is a monopole, it has positive charge. Minus 3 is a monopole. But when we have collection of monopole, for their strengths calculation, we can add the charges together, and this is what is called monopole moment. Now this was about monopole, and this was easy, we have studied also. Now comes dipole. So from the term it's clear that di means 2. So it's a system of 2 charges. This is fixed, as when we use the term 2 di, it means 2, system of 2 charges. But it's not just 2 random charges that can be taken. You cannot take this plus 2 coulomb and minus 3 coulomb to make a dipole. Dipoles have some fixed conditions. When we talk about dipoles means that they have a small separation between them. Positive and negative charges will be present. Now, how to identify a dipole? Magnitude will be the same. Means if I take Q and the second charge has to be Q. This is what is meant by a dipole. With one more condition, the signs have to be opposite. They can never be like charges. They always have to be unlike charges. If this is positive, this is negative. So it will always be plus Q and minus Q. And they will be separated by a distance. This is what is forming a set of dipole. This is our dipole. This is called a dipole. Like you have H plus ions, they are associated with Cl minus chloride ions in HCl molecule. So this also forms a dipole when the magnitude of the charge is the same. So magnitude also has to be the same. I cannot take 2 coulomb with 2 coulomb. This won't make a dipole. I cannot take 2 coulomb with 4 coulomb. This won't make a dipole. For 2 coulomb, I would need minus 2 coulomb only. This will only form a dipole. So first is identifying dipole. This is the dipole. Next is what is this dipole moment? Like you had monopole, monopoles led to the monopole moment. Similarly, dipole will lead to the dipole moment. So when we're talking about the dipole moment, means you are calculating the magnitude and the strength of this dipole. Dipoles can be, identification of the dipole is important. So dipoles can be identified first. Second, you have to calculate their strength. Now, how do we find out these dipoles? So look, the two dipoles, basically the two charges, one charge is plus Q, second charge is minus Q. And both the charges are separated by a distance which we say 2a. These are the charges which we say 2a. Separation we say as 2a. Now, when you are calculating the dipole moment is represented with the help of this P with a vector. P with a vector because it's a vector quantity. How do you calculate? See, magnitude is the same. You take any of the charges. I'll take Q because it's both are the same. You take the magnitude of one, don't write it double, multiplied it to 2a. This is the whole formula of the dipole. What is P? P means the dipole moment. Q is the magnitude of charge. It's the magnitude of charge. And see, 2a is not the double of the distance. 2a is just the separation between the charges. If separation says 3 meters, your 2a will be 3 meters. Separation is just 3 meters. means 2a, because by looking at 2, it seems as if we are doubling the separation. So no, 2a simply means the separation between the charges. So this 2a means the separation between the charges. That's it. What all you need to know about a dipole moment, that is important. First, it's a vector quantity. So if it's a vector quantity, it will have a direction. So when you're talking about the direction will always be from the negative atom to the positive atom. This is its direction. Ali, can you tell me the SI unit by looking at the formula? Hmm? Coulomb meter, correct. SI unit will be coulomb meter. Coulomb for the charge and meter for the distance, right? SI unit will be coulomb meter, correct. So these are the things that are important. Let us see a small question also based on this. An easy question. Look, this says that two charges are present. One is plus 5 microcoulomb, second charge is minus 5 microcoulomb, and they are separated by 1 millimeter. We need to calculate the dipole moment. It is equal to charge into 2a. This is the formula. So Ali, can you tell me what should I write instead of charge?
5.
5. Done.
5 into 10 to the power minus 6.
Because it was micro, na? So yes. Multiply 2. The separation,
10 to the power minus 3.
correct. 1 into 10 to the power minus 3. So this becomes 5 into 10 to the power minus 9 coulomb meter. But what's the direction? Towards left or right?
Towards left. Towards the right.
Towards?
Towards the right.
Towards the right or left?
Towards negative charge, no?
Towards the negative
Negative
charge.
charge.
See, direction is from the negative to the positive. Okay. So direction will be towards, earlier one was right, left. So I'll write it as minus I cap so that you remember, or you can write towards left from the negative to the positive. Is this concept clear to you, Ali?
Yes, ma'am.
Okay. Please write it till here. Okay, see, this is the second question. Here we have to calculate the dipole moment. Now, the charges are not given directly, they are present on the z axis. And both the charges, the coordinates are given instead of the separation. So, for the dipole moment, see, the dipole moment has the formula. You take the charge, you multiply it with the separation, that is 2a. Now, Ali, you tell me what's the charge? Hmm?
2 into 10 to the power minus 9.
Minus
9.
minus 9. Why? What is 1 millimeter equal to?
10 to the power minus 3.
So this is also milli only, no? 2 millicoulomb. So not 9. When it is 1 nanometer, 1 nanocoulomb, then it is 10 to the power 9. This is 1 millicoulomb. So milli is 10 to the power minus 3 coulomb. Okay. Now, Ali, can you tell what is 2a in this question?
Four into 10 to the power minus 3.
Yes, right. See, this part is given as 2 millimeter. And this part is given as 2 millimeter. This is just telling the position from the origin. But when we take 2a, we take the separation between both the charges. This is 2 millimeter, this is 2 millimeter. Total will become 4 millimeters. So we are going to write 4 into 10 to the power minus 3 meters. Now, when we are calculating the dipole moment, this is simply charge 2 into 10 to the power minus 3 multiplied to the separation. Just check the separation. Take where are your charges and their separation. That's it. That is what is your 2a. So it will be 4 into 10 to the power minus 3, which is 8 into 10 to the power minus 6 coulomb meter. Now, can you tell, see, axes are also mentioned, the direction. Towards which axis?
Towards
Towards
z axis, no?
negative, positive.
Positive.
Negative,
Positive.
positive. Yes. See, it will be positive. It is from the negative to the positive. Remember, dipole moment will be there in your chemistry also. And in chemistry, the dipole moment's direction is opposite. It is towards the electronegative element. But in physics, you have the direction from the negative element to the positive. So your final answer can be summed up as this much k cap coulomb meter. Okay. Write this also, Ali.
Done, ma'am.
Okay. Now see, this was the complete separate topic of dipole moment. Now we'll have this. I hope you already remember. I just wrote if you have forgotten. Universal unit vectors, what are they and their direction? I think you already remember them. Now see, we will be talking about electric field due to these dipoles. Dipoles we have studied separately. Now in our questions, a set or you can say pair of dipoles will come. Dipole means a pair only. So there are two cases that are there in your syllabus. One is axial line of electric dipole and one is equatorial line. Now, what is this axial line? See, this is a dipole. When I extend its axis on both the sides and the point is intersecting on this axis, we will say this is the case of axial line. Now, we will solve this. This is basically a derivation and this derivation is important. In some of the sets, axial is given and in some of the sets equatorial is given, like this in your final boards exam. So we will solve it the way we have to solve a normal question of superposition principle. And you will see a result is formed. If you can relate, before this question, before this whole topic, at the beginning of the class, the point B which we discussed, wasn't it similar like this? Minus 10 to the power 8 coulomb and plus 10 to the power minus 8 coulomb. This was separated by 0.05. Yeah.
No.
So that was actually the axial line of electric dipole only. So now we will solve it in that manner, how we have solved it there. So we will do it similarly. Now, Ali, tell me one thing. Due to this positive charge, what should be the direction of electric field? Right or left?
It's right.
Right, because it's a positive charge, so it will be pushed away. This is E plus Q, and this is the negative charge, so it will be pulled towards it, E minus Q. Now, I require one more separation apart from all these things. 2A is the separation between the charges, and half of them has the separation A. Means when I cut the dipole in half, I will get one part as A, because total separation is 2A itself. Now, from the center of this dipole to this point P, I am going to take this distance as R. From the center of the dipole to the point of calculation, we are going to take this as R. Now, when we are going to calculate the electric field, now Ali, I'm again saying, whenever you have the exams, when you're doing the derivations, you have to tell that let R be the separation from the center to the point P. Like this, you have to mention everything. Let Q be the magnitude of the charge and everything you have to mention. 2A is the separation between the charges and A is the half of dipole and everything you have to mention. E plus Q will be towards the right. These things you have to explain. You already know that's good, but you have to explain it in your answers. Now, when I write E plus Q, means due to the positive one. Tell me what will be the formula of electric field due to the point charge?
KQ by 2A square.
KQ by 2A square. See, plus Q means this separation, no? Just this. This is not 2A. See, this total is R. This part is A. So this will be
R minus A.
R minus A, exactly. So it will be R minus A whole square. Similarly, when we are calculating it for the negative charge, when we are calculating the negative charge minus Q, so this negative charge is far away from here. So it will be KQ divided by. Tell Ali.
R plus A square.
R
R plus A.
plus A whole square. Right. See, this is R and this extra part is A. So total separation is R plus A. Now we will calculate the resultant here. So for the resultant, we require the magnitudes, which we have already calculated. Now we will calculate the resultant electric field at this point P. Okay. So when you're calculating the resultant P, you can see both of them are in exactly in opposite direction. So what we will do, for the net electric field, we'll subtract it, right? So see, this will be KQ by R minus A whole square minus KQ by R plus A whole square. Now see, in order to solve this, I will take KQ out and I will have R minus A whole square minus 1 by R plus A whole square with me left. Okay, so look, now solving this is our task. So KQ I am keeping here. Now let's cross multiply it. This will become R plus A whole square minus, this will be R minus A whole square divided by, we will multiply these two. So R minus A whole square into R plus A whole square. This is it. Okay. So this is one is R plus A, second one is R minus A whole square. Now, isn't it similar to some identity? Can we write it as some identity?
Square minus B square.
A square minus B square, this one.
Or A plus B whole square.
A plus B whole square. So R square plus A square plus 2AR. Similarly, this is R square, but because of the negative sign, it will become minus R square. Plus A square, because of minus, it will become minus A square. And minus 2AB, minus 2AR, minus minus will become plus. Plus 4AR divided by. Now this, can you tell which identity is this? A minus B into A plus B is equal to A minus B into A plus B is equal to A square minus B square. Okay, so this will become R square minus A square to the power whole square. Clear? Okay, so Ali, I'll continue it in the next class. Now time is not left, and this copying part also, once we derive the whole equation, we'll complete this